Hello guys and welcome back. So now we're going to take a deeper look at the material network here. And this is a new context that was introduced in 15.5 or 16 I believe. And the old one was called shop. And if we go to the shop context, you see when we hit tab the list is much smaller. And the reason for that is because we don't have access to all the nodes like we do in the mat. And so what side effects wanted to do is give the artist access to everything at the same level. So for example, if we wanted to create a noise pattern, we can grab the position, the shading position. So created a global node. I'm gonna import the surface position and I'm gonna connect that to the base color. Let's say we wanted to add noise to the diffuse of this node here. Let's change this to 3D noise. Previously, doing this cannot be shared between multiple shaders. You have to copy the nodes. But with this context, everything is flat, everything is accessible. We can share nodes between different shaders. Now, this feature I rarely use, to be honest. I like to have everything in a subnetwork where and isolated, because the shader can quickly get messy, especially that if we wanted to create something custom. So sharing the nodes between the graph is not something that I care about too much. And what I'd like to do is I'd like to create a material shader builder and think of this as a context or a container or an empty shader basically that we can use to do all our shading. So I'm going to drag this node here. We can dive inside. It has a couple of inputs and outputs that we need to feed for it to work properly. So for the displacement, we don't have to worry about that, as well as this. And this is if we wanted to read the normals, the point positions, and things like that, we can access that here. And then for the surface output, this is where we can connect either the principal shader, for example, or create our own. Now, I like to create my own shader from scratch. And if we right click on this node and say allow editing, we can dive inside and we see it's built off a lot of small components. And these components are called BSDFs, and this is the lowest level of the nodes. If we dive inside this principal shader core, we see all these nodes are just preparation and feeding textures and things like that. And then the main logic is happening here. So the principal shader is the one that does all the magic. And if we dive inside this guy, we see there is BSDFs, and these are the actual BSDFs that does the computation. So we have the PBR non-metallic, PBR metallic reflection. We have a PBR diffuse. This is for the sheen function, the Fresnel function. This is the PBR diffuse, and all we need, for example, to get a diffuse instead of all those nodes, we can use a PBR diffuse directly here. So to feed this, to connect this properly, we need first a compute lighting node, and this is important if when you have multiple lights and you wanted to make use of all the AUV features and things like that, it's important to have this node, especially with the raise algorithm that we're going to take a look at later. So I'm going to connect these things, and then you can see we have a layer node. We can connect the BSDF as well, and now we have a simple diffuse. Instead of 500 nodes, we can just do this. So let's go back. Let's go here and hit render. Now, I'm not saying don't use the principal shader. It's definitely a great shader. It has a lot of cool stuff, but we can also create our own from scratch, and I think this will allow you guys to learn more about shading in Mantra. Okay, cool. So we have a diffuse shader. Let's add some specular to it. So we're going to create a PBR reflection. Okay. And you see here, for example, there's different modes that are not exposed in the shader. And what side effects did is they try to expose the controls that makes the most sense to the artist, so that this thing is an artist-friendly tool, where you have a slider that makes it from gold to non-metallic version, for example, which is great. So if you need that, you can use it. But we can also make our own BSDFs. This is what these nodes are called, and we can combine them. So I'm going to use a layer mix, and I'm going to combine these two guys. Okay. I don't need the F. And this layer mix will take care of the energy conservation feature because it's been taken care of here. So whatever reflection we have or code or anything, we're not going to get overexposed result. The energy conservation logic is light coming in is equal to the light is less or equal to the light coming out. And if we have a lot of VRDFs being added in a non-physically accurate way, in a non-physical way, the physicality is going to break. But with this layer mix, it knows how to mix these two guys. So I have a PBR reflection, and we can also have access to different BRDFs, different reflection algorithm, or different reflection functions. So we're going to keep the GGX, and this is the roughness. And again, side effects expose certain controls from here that we can use. I'm going to turn on shade both sides as front in case there is flipped normals, and let's hit render. And now we have a reflection added on top, and see how the diffuse gotten darker. That's because it's balancing the diffuse value with this PBR reflect, so it doesn't get bright more than what it should be. Okay, cool. So we have a simple shader with just two components. Now I want to do something in SOPs. I'm going to go back here. I'm going to dive inside the statue, and what this is actually is from week 3, and it's animated. And to be clear, this week we're going to learn a lot of stuff about shading, but we're also going to learn a lot of stuff about SOPs and creating things in Houdini, so not just pure shading and rendering. So we have the animated geo here, and let's say we wanted to find a mask where the object is being eaten. So as this progresses, I want to be able to isolate this data and create a mask that I can use in the shader to drive different values, or for example mix between two different shaders. Let's say we have a gold version and this is becoming a darker gold, or mud, for example. We can do whatever we want. So let's how can we solve this? Well, if we do a time shift, set this to 1, and I'm going to template this, and let's scrub through. And as we scrub through, we can see that the original surface is always there's always something close to the from the surface that is getting eaten. There's always a portion that didn't change. Okay, there's always something close to it, but the stuff that has been eaten, there's no geometry next to it compared to the original one. So if we do this, if we create a color here, set it to red on this time on the first frame, so this is the original geo, and let's set this color to black on the second animated geo. Let's go to a different frame here, for example. If we transfer the color from the red into the black object and use a very small threshold, we will be able to create a mask. So let's create an attribute transfer, and this allows us to transfer data between different geometries based on the distance. So here I'm going to transfer the color, which is the CD attribute, and if I go to the conditions, I'm going to set this to 0.1. And by doing that, you can see now we're only transferring colors between this surface and then this, but all the stuff that is inside, there's no surface close to it. Okay, so you see we're getting a very cool mask now. Let's lower this to 0.01. So much, 0.05, something like that. And sometimes the there is not enough data to transfer from the original, the source to transfer from does not have enough points, because the transfer is happening at the point level. If we look here, sometimes like this area, for example, doesn't have enough points, so it may not be accurate when we do the transfer. And to solve that problem, you can simply scatter a lot of points. I'm going to turn off relaxation. I'm going to increase this to 100,000. Okay, and now